Hi everybody, welcome back to our session where we're going to detail the recipe on making candy glass. This sugar glass, of course, will be useful for many of your experiments that you may have seen on our website. But today we're just going to focus on the details of making it and hopefully give you a good close-up of what's happening while we're making the glass. Of course, the hard candy or candy glass, sugar glass, is made from three primary ingredients. We use the cane sugar, we use some additional Caro to help reduce the crystallization, and we use water to make the candy glass. There are instructions which are on our website, which will help you go through all of this. But let us begin. I can tell you a little more as we go. First thing we're going to need to make our candy glass is the idea was you would make it on your stove, or you could make it on a burner like this. I've done this in my own living room so we can see how easy it is to make at home. So, as we mentioned, there are three ingredients that will be necessary for making the candy glass. We will have some sucrose. We're going to start out with 120 grams of that. Our recipe will then have 60 grams of the Caro and 20 grams or 20 milliliters of water. So let me begin by measuring out the Caro. I am using here, I'm making measurements by weight, which is more accurate. We could also do this by volume, and I think I've given in the website that if you did it by volume, you use a half a cup of the cane sugar, you would use a quarter cup of the Caro, and you would use 4 teaspoons of the water. You can consult the website for that. But it's far more accurate to use measurements by weight. So, I'll start out with a 400 milliliter beaker, using my scale here. We will tare that weight. Let's start over again. I think I put something on before it was ready. Okay, now put my beaker on, tare the weight. And how much did I say? We're going to use 60 grams of this Caro. Now, I'm going to cook this glass in this beaker here. And so I find it easiest to put my Caro in last, or as my first ingredient, it's the last thing I measure out. Alrighty, so here we are. I put in a little too much, so what I will do is take a spoon, 59.9. That is good enough. So, let me get rid of the rest of that. Okay, so now I have 60 grams of the Caro. I have 120 grams of the sucrose, and in order to dissolve this mess and make a glass, that's really a lot of what the water's doing here. I put in my 20 grams or 20 milliliters of water. You can see it's all very dry and gooey. Now, note the state of this material as we begin. It's just a very white, undissolved mixture, as you can see, because of all the white little particles in it. What we are going to do is heat that up first of all to dissolve it. And, excuse me, but I must turn my power on. Okay, now I've got my... And somewhere in that setting. Okay, now while that's heating, there are a few things that we might want to mention. First of all, if you're doing this at home, you could just as well cook this into a saucepan, and I would use a very small one. You don't want to have too large of a volume, you want to have some depth to it. This works out fine. I'm using the beaker today so that you will be able to see through what is happening, because an awful lot of interesting chemistry and physics is happening with physical properties being exhibited. So we want to be able to see that. Good time to mention that there are some safety issues that you should be concerned about. It's a good idea to be wearing either glasses or safety glasses. Make sure in case anything would boil and splash up, your eyes would be protected. The other thing that's important is this material will get very hot. You need either a cooking mitt or some sort of glove to be able to handle this material safely. Boiling water is at 100 degrees, very hot. We are going to be getting much hotter than boiling water. We'll be getting up to 140, 150 degrees centigrade. This material is very hot and can burn you. So you must be very careful when you're making that to pay attention to your safety issues. All right. Now, let me mention that there are some things when we start making the candy. Let me bring your attention now back to the candy glass being made here, and I'll make my comments later. But I want you to notice that on the bottom there, you start seeing some boiling happen. And hopefully you're getting a nice close-up of this so that you can see. Now what's happening here is the bubbles are starting to occur on the bottom where those hot heating elements are. We in fact don't know what the temperature of the solution is, but we would like to. So we are going to insert a digital thermometer. You can see the digital thermometer here. It will help us keep track of the temperature. Oh, I want to keep an eye on how long this procedure takes. So let me start my stopwatch at this point. We probably lost a minute or so, but we haven't been cooking that long. Now, as this procedure goes ahead, I would like you all to be paying attention to a few issues. First of all, as we mentioned already, that the initial state of the mixture is cloudy, and that's because it represents undissolved material. I'd like you to be noting when the bubbling starts, and certainly the bubbling has already started, even though our temperature is, so it was well below, let's say, 70 degrees. The point is that the bubbling starts because the material on the bottom is hotter than the whole solution. The next thing I would like you to pay attention to is what's the temperature at which the boiling starts to happen vigorously throughout the solution. And by that, I'm really trying to call our attention to when is the boiling happening, when is the whole solution reaching boiling. Notice it's just on the bottom for now. The other thing I would like you to pay attention to is the temperature at which the solution begins to clear. Right now, as you can see, that solution is very milky and cloudy, so we'll want to note that. And then we're going to want to look at when it starts forming threads, which is what will happen before it forms a glass. And finally, we'll be looking at the temperature at which it forms what we call the crack, or the hard, when it's appropriate for making hard candy. Okay, so we'll keep watching this solution. Remember, we want to note when this solution is actually boiling. There are other thermometers that you can buy. This digital thermometer I have out there is real nice because it has a long arm that you can put in and keep your instrument away from the solution. This one here is cheaper, and I could put that one there we go, right in on the top. I am going to, okay, I want you to, I'll put that one in too for now. I want to stop this for a second because, where's my glove? This is why you want to keep your glove handy, because this solution gets very hot and it's started to boil. So what I need to do is just pick it up a second, let it cool. Now, notice what's happening in the solution. And I'm going to note that the temperature there says 110 degrees. Now, can the camera catch that if you look in on that solution, it has all of a sudden become clear? So we had a very rapid boil begin. That's that rapid boil that I want. And notice also that the solution has become clear. So the temperature at which the boil began vigorously was about 110 degrees C. And the temperature where the solution clears, well, in this case it was about 110. Sometimes, depending on the recipe, I just made it stop boiling so you can see that. But sometimes, depending on the recipe, the boil temperature and the clear temperature are not at the same spot. It all happened pretty quick here, so approximately 110 degrees. Now it's back on the heat. We'll let it go a little more slowly. Essentially, it's clear because we've dissolved all of the sugar. We now have a single solution with everything dissolved in it. We refer to this as an isotropic solution, meaning that it is all uniform within. Isotropic really meaning the same in all directions. So, our solution is clear. It's boiling. We're pretty much set now for a while. What's our temperature right now? 112 degrees. Okay, sometimes I like to check, see how the one on the top is doing. Okay, 113 there, and over here it's 113.7. So there's a little bit of difference between the two, but they're basically giving you this pretty much the same answer. There can be a difference because this has a much longer metal piece that has to be heated up. Okay, so we'll just let those go. You can see the nice boiling. Let me talk, while this is happening, briefly about what's involved in making the candy. In making candy, we use water and heat to dissolve the sugar. We use two different types of sugar. We use the sucrose and the caro because if you just use the sucrose, we would have very considerable issues with the crystallization of sugar as we started to try to make our candy. So the additional sugar, the caro corn syrup, really helps to suppress crystallization. Most recipes will involve both types. All right, so we add water, and in this case we added about 10% of our volume was water. And the amount of water that you add, well, hold on a second. We add the water, but in order to make it into a candy, right now we would just have a syrup. In order to make it into a hard candy, we must actually boil that water out. That's what's happening now. We're boiling the water out to make it a sugar mixture of much less water. Now let me come to this curve. As you boil out the water, the temperature at which it boils begins to rise. This is some data from a wonderful book by Harold McGee. It's called On Food and Cooking. I think it's the Science and Lore of the Kitchen. And here we talk about the sugar water solution and the temperature as we remove more and more of the water as we get to 100% sugar. Notice he gives the data in degrees Fahrenheit. We like to use degrees centigrade because we are it's the unit of scientist. So here's 110 degrees C. We're talking we started boiling at about 110. So our solution was about here, agreeing maybe there, agreeing fairly well with the concentrations here. We are now at 117 degrees and about 7 minutes into our cooking here. What we need to do is to continue to boil this thing until we've boiled off enough water that we get to this very low, below 5% of water. And at that point, the material will start to be high enough sugar concentration to make a nice glass. It's also when we have to watch that crystals don't form, because as you recall, glass is a state in which there are no crystals. It's an amorphous state, it's a non-crystalline state, and it's metastable. Okay, now how did people do this in the old days? Well, people didn't have the thermometers that we have to make life so easy in terms of knowing what temperature is. But they had invented their own methods in order to tell when you were ready to make the sugary solution into a candy. And part of that was, the way they did that is that they had what we call a drop test, or a softball, hardball candy test. And we're going to be doing that ourselves. Let me use the glove on this hand. Now remember, everything you've stuck in here, this is 118 degrees right now. This is very hot. This is very hot stuff. 116 degrees over there. Notice when I bring that spoon out, the drops fall, except can you begin to see a little thread type string has formed as I drop, as it cools. See, what's happening is it's cooling, so we're seeing what the state of this solution is at a cooler temperature. That's showing you that this solution is starting to become a more complex solution. Certainly water doesn't behave like that when it melts. All right, but we're still in the syrupy stage. Now, the idea of the softball test is as follows. Let me switch back to my right hand. We will take a sample of this solution and we will cool it to room temperature by dropping it into some cold water. We'll just put a couple balls in there. Now, I don't know if you can see that, but there are little balls there. Just get a flashlight to help spotlight those. Are they showing up? And if I put my finger in and start mushing, here in this cold water, this is no longer just a solution. This is very gummy now. And you see what's happening? It's actually gummy and stringy. That lets us know it's beginning to make a candy. That's what we call a softball. Well, that's maybe a little before softball. So we're going to watch as the temperature goes up. We're at 119 degrees over there. Now we're seeing slightly higher temperature on this one. And that's one of the reasons why I don't like to use a saucepan too, because the temperature will not be accurate unless the thermometer is immersed in the solution as deep as it needs to be for the whole sensor. And in this case, it takes about 2-3 inches of solution. If you put it in a saucepan, you have to be very careful that you're not reading a lower temperature. Okay. The only disadvantage of the beaker, of course, is it always concerns me as to whether it would break and there'd be a lot of hot, because it is glass, and a lot of hot solution. So I would recommend being very careful if you're doing this on a table. Keep it in a cookie sheet or something where you're always prepared for it being able to break. Okay, so let's make another test. At this point, there's my spoon service. $123 on this thermometer. Take out a sample. Put it back in. See, this is still sticky enough that when it sticks to the bottom, it's getting into a ball, but it's really taffy. We're at the taffy state of candy at this point. It's got some guts to it, but it's still, well, there's no better word than taffy, I think, to describe it. I use cold water, which really helps to chill it off faster. Now it starts to stick to your teeth. And this is kind of fun doing making the candy, but it'll start to stick to your teeth. You can really feel the material's developing some guts to it. And that's it's fun. Here's another safety thing to warn you about. Because we are making hard candy, which has a glassy type of nature to it, as you start to have little fine strings of this candy glass, you have to be careful. I mean, they can get in your mouth and feel very sharp too. So try to avoid letting any of these fine strings of glass. Be very careful that you let them dissolve in your mouth and don't let them get caught in your throat. Okay, so where are we at now? Over 127 there. Yeah, about the same here. Turn the heat up a little to make this thing progress faster. I think we will come back to maybe at about 132 or so. I'll make another test. All right. Okay. Let me make a test now, because I'll tell you what's going to happen is as we start boiling off the water, this all goes very quickly. Oh, let's do some string test. Okay, you see the strings are starting to form. Here we're 130 degrees, but they're definitely getting nice long strings that are coming off my spoon. This material is changing. It's changing very quickly now. My thermometer inside the glass is seeing 133. I think it's time to make another ball test. 1, 2. Now, I can see, I hope you can too, now, see, I was tempted to touch that, but don't. It's very hot. There are little strings, even as it falls in the water, that are forming on this material. Let me see if I can pull one out. Can you see the little tail forming on that guy? Whoops. Can you hear that crunch? Or did I hear it? It's a soft crunch. Hard enough that it crunches instead of like taffy, but it's also gummy and sticks to my teeth. 142. This is generally where I know to be that I'm probably going to get my candy. I want you to listen for something. I'm going to turn that heat down because I'm 144. When I put it in the water, listen very carefully. Okay, so everyone be quiet now. Nope, I didn't hear it yet. We'll try again. You often will hear a crack as as it goes in the water. It's definitely cracking as I eat it. These are hard candies now. These little balls are definitely making hard candy. I'm up to 153. Let me take, and where are we at? 17 minutes. Okay, let's listen again. See if I can get a crack sound. We're listening for a crack. Can you hear that? Let me put some more in. I'm hearing it. Hope you guys are. Oh, did you see the threads that are forming inside there? Go one more time for a crack. Okay. Now this is, I see a beautiful little guy with a tail. Can you see him? Very glass-like. This is actually what's called a Rupert's drop. These things have an incredible property if, let's see what happens if I break the tail on this one. No, he didn't do what the, but these things are very crunchy now, very hard. We've certainly got to the hard crack stage. Lots of little, you hear that when I go to crunch it? Very, very glass-like. Okay, so now we've made our material. 157 degrees. Just record where we stopped. 157 degrees stop. I would say the temperature for the crack it was about 150. Now I'm going to take some of this out. Remember, this is very hot material. So be careful how you handle it. Have plenty of places at home where you can put your, utensils. Now we're ready to make things with this. If in fact you're ready to do some science experiments and you want your candy glass or something, let's let it cool off. First thing, notice all the bubbles. The bubbles, of course, are the water coming out. I like to let those bubbles settle out. You can handle this material for a little while. We may want to have samples that we want to study in a test tube. I have some experiments that I'm working on. I will certainly want some of those. So remember, this is hot. It was 150 degrees. So I will get ready to prepare a few of samples for some experiments that I have coming up. Okay. Now, notice the boiling and bubbling that still goes on. I have another. Now I can feel that getting warm through my glove. You must get a little sloppy here. We'll worry about cleaning up later. First thing is to keep our eye on safety. So we've made some. Now there's another type of sample What you might want to do if you're interested in making thin slides to study glass, thin film glass. The way I like to make these is I use some little washers as spacers. Put another little glass on top. There's my first one. There's our second one. Now there's a young student who's done a wonderful experiment in high school to study the rate of crystallization affected by moisture in candy glass, and she develops this procedure for studying those. So there we have 3 nice little circular samples we could work with. Or maybe you're just interested perhaps in, now notice, see how it's forming little glassy pieces already, but you say, well, maybe you're really just interested in having some fun and maybe making some candy glass for popsicles or for some, lollipops. So in this case, I would make my lollipops by using a popsicle stick. And come on, fill that hole in. There you go. There's one lollipop. Whoops. Or perhaps you want to write some letters and make your name. But this is where the material starts getting interesting. Can you see the strings that are coming off? See, now as it cools off, it goes through a stage where it becomes very taffy-like, and it's in this taffy-like stage that we can form this material. We can pull it into strings, and those glass strings, this is how one makes the fiber optics. Fiber optical communications, by taking an inorganic glass and pulling it like that. Of course, they are edible in our case. Now, we've basically gone through the procedure. We have a lot of very interesting material left over. Notice how clear it's becoming as it's thicker. The bubbles are all gone. This is a chance where you can do a lot of different things with the material. One of the things I've been interested in is seeing whether I could make like a pane of glass with it. So let me get another sample over. You might want to consider making a uniform sheet of glass, like one would do if they had a window pane. So we're making the window pane. I've taken aluminum foil here, and I have sprayed it with some cooking, some Pam, to see if we can keep it from sticking. And we'll find out later how successful that is. So now we're into some of Bill's new experiments here, seeing what we can accomplish. And with that, we'll catch you guys on the bottom side when we look at our samples, and I hope you find this a useful demonstration, or are able to make some of these glasses and many of the modifications that you yourself may come up with. Thanks for your attention.